Theorem 6-6 states, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So if ABCD is a parallelogram, so we're going to draw ABCD. Then we know that line segment AE is congruent to segment CE, and BE is congruent to DE. And to show that, we go back to the parallelogram. And we know that those are congruent. So problem 3, using algebra to find lengths. I went ahead and drew the parallelogram from the chapter. And now we're going to solve a system of linear equations to find the values of x and y in parallelogram KLMN. So we are looking for KM and LN. So first, the diagonals of a parallelogram bisect each other. So we know KP is congruent to MP, and LP is congruent to NP. Next, we have to set up a system of linear equations by substituting the algebraic expressions for each segment length. So we have to substitute them in. So we have y plus 10 equals 2x minus 8 right here. And then we have x equals y plus 2 right here. So the third thing that we have to do is substitute y plus 2 for x in equation 1. Then we have to solve for y. So what we're going to do is y plus 10 equals 2, in parentheses, y plus 2 minus 8. Just plugging it in. And then we're going to solve. So we get 14 equals y. Next, we have to substitute 14 for y in equation 2. Then we solve for x. So we're going to substitute it in. X equals 14 plus 2. And then we know that it equals 16. X equals 16. Then, we are going to use the values of x and y to find Km and Ln. So Km equals 2 Kp. So equals 2 y plus 10. We know that y is 14, so we're going to substitute that in. And then we get Km is equal to 48. Next, we're going to find Ln. We know that it is 2 Lp. So it'll be 2x and we know that x is equal to 16. So we're going to substitute 16 in. And now we know that Ln equals 32. So these are our answers. Km equals 48, Ln equals 32.
Theorem 6-7 states that if three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So if AB is parallel to CD, and CD is parallel to EF, and AC is congruent to CE. So then we're going to draw a little diagram, and we just need 3 lines with arrows on both sides. And then we're going to label them after we do the slanted line. So then we're going to have our slanted line, which is going to be labeled E, C, A. Then on the other side, it's a little more slanted than the first one. It will be labeled B, D, F. So then BD is congruent to DF. Problem 4. Using parallel lines and transversals. In the figure, AE is parallel to BF, is parallel to CG, is parallel to DH. AB equals BC equals CD equals 2. So then EF equals 2.25. What is EH? So we're trying to figure out what EH is. So we'll start out with EF equals FG equals GH, and then over here is, since parallel lines divide line segment AD, into equal parts they also divide EH into equal parts. So the next step is EH equals EF plus FG plus GH. So that's the segment addition postulate. We'll just add the segments together. And then down at the bottom, EH equals 2.25 plus 2.25 plus 2.25, which equals 6.75, which is the substitution. So you substitute there, so EH equals 6.75.
Do these 4 problems as the lesson check for a candy question at the end. That was 6-2, properties